All right. At this video, we are going to talk about units. Units, everything, whatever we do in our life, we all somehow you use units. What we say, we want to talk about distance first. Meter. This is the unit of length. Meter, we have kilometer, meter, and centimeter and millimeter. We if like between two cities, the distance is we don't say like is 22,000. 22 million. 22.5 million centimeter. We don't say that. We say, see, this is if centimeter. We have to change it to meter and then kilometer, or we can change it directly to kilometer. It's. If we divide by 100, 20, okay, if we divide it by 100, it's going to be 5, 0, 0, 0, yeah. Actually, no, it's 5, 0, two of them got it 3, 0. See, actually what happened is, say 100, two of these cancels out, and if we use division here, so that is in divided by 100 is going to be meter. See, what we did is say whatever change centimeter to meter. What you say, like this is 22 million 500,000. We say this is centimeter. What we do is say is 100 centimeter is going to be 1 meter. And so we are going to change it to meter, so it's going to be, this cancels out, and 20 with this 20 is going to be this. Okay. Now we are going to change the meter. This is meter to kilometer. See, every 1,000 meter would be 1 kilometer. So you divide it by 2. The way you do it, you say we have 25,000 meter. If you're going to change it to kilometer, you say every 1,000 meter is going to be 1 kilometer. You write the units, the one down that it can be cancels out. So 225,000 is going to be divided by 1,000 is going to be 225 kilometers. We say the distance between these two cities, 225 kilometers. We don't say this 22,500,000 centimeter. Just want to let you know, depend between the like between the distance between Earth and the Sun. Earth, say like 150 million kilometers. They use million kilometers. It depends on the distance. Okay, we don't want to. That's enough for that. If you want to change, like one thing is say, we say 12 inch is equal to 1 foot. Okay. So if you have 5 feet, to change it to inch, we say 5 feet multiply. How many feet? 1 foot is going to be 12 inches. So there are 5 of them. It's going to be 60 inches then. 5 foot is going to be 5 feet. It's going to be 60 inches. So we write this. You know, we talk about let's talk about the linear equations. We say we have two axes, x and y. But this y, this could be anything. You know, if you want to write, for example, it could be the unit of this one is going to be time. This is time axis, which is in hour, for example. And this is the distance f of t. We say f of t, function of t. Okay. You can use it, use different people, different things. The h of t, g of t, whatever. You know, we. Let's see, a car is going 60 kilometers per hour. You know, there is a car going in a constant speed, means at 1 hour is going to go 60 kilometers. And the second hour is going to be 120. This is the unit. You write the unit here, kilometer. Is the distance, kilometer per time. And then at the third hour, how much? 180, and so on. So we say that let's find the slope of this, as we talked about it earlier. We get to point, find 2 points. You know, we have x and y, or here t and kilometer. Time, this is time, and the kilometer. The first hour is going 60 kilometers. It's just a constant speed, putting on cruise control, you're just going exactly 60 kilometers, for example. You know, let's find the equation of this. You know, this is a t and f of t is a function. T as a function of f. This is y. We call it the Latin x. This is in kilometer. And this is in hour. So the distance is in kilometer. So we say we know 2 points. M is equal to 2 points. Y2, this is 0.2, this is 0.1, and we say y2 minus y1, x2 minus x1. Means the difference of the y's, what is the this? From here to here, we say y2. Y2 is here. This is y1. 2 here is 180. And at point 1, y1 is 60. Say it's at minus 60. And x2, how about x? This is x from here, x1 is going to x2. So x2 is going to be 3 and x1 is going to be 1. I mean x2, you know, in 3 hours, has passed 3 hours. But when we use the from first hour to this one, you know, we write the coordinates x and y. Okay, what's going to be? This is 0.2. X and y is going to be, x is going to be 3. You know, x and y means vertical axis, horizontal axis, and this is vertical axis. The coordinates of this, the horizontal, the vertical is 3. So we said 3, and y is going to be 180. Okay, 3 and 180, and the point 1, x is going to be 3, and y is going to be, I'm sorry, 0.1 we're talking about, 1, and y is going to be 60. Okay, 2 points, we have 2 points here. The y2 minus y1, x2, this is 2, and this is 1. Okay? So it's y2, this is y2, this is y1, I'm sorry, x2, y2 at the point 2, we have x1, y1. So y2 minus y1 means 180 minus 60 divided by x2. x2 is 3 minus x2 is 3, and this is 1, x1 is 1. Okay, it's going to be 120 divided by 2 is equal to 60. 60, what is going to be? 60 kilometer per hour. See, the unit of this one, why we got it 180, what is that? Is the kilometer. A 180 kilometer, you know, at the third hour, it's gone, the distance has been 180 kilometer. It's gone 180 kilometer up to from here, for example, to Nevada is 180. You know, there is a city just next to it. Is 180, and the speed of the car when it started is 60 kilometer per hour. So in 3 hours, the distance that this vehicle is gone is 180 kilometer. So this is kilometer, and this one is t. T in what unit is hour. So 60 kilometer per hour. Okay. Okay, let's find the equation of this one too. It's interesting that see, linear equation is just one of the important things in college algebra, mathematics, and higher math. Because if you learn how to find the equation of a line, it's very, very important. I mean, if you don't know this, then you know you are gonna have trouble. Equation of a line, you know, we'll talk about it. We just started. We're going to talk about it a lot, you know, because it's very important things in mathematics. So let's find the equation of this line. We have m. M is equal to 60 kilometer. We don't write here. We can write kilometer per hour. See, the equation of this line, we say that y is equal to mx plus c. There is a constant. I know I can see the constant is 0 because all it started from 0. This is doesn't have y. Okay, you know, we'll talk about c later. Okay, how do we find this? If you have one point, like the point 2, for example, x is 3 and y is 180. We have x and y here. Y. Okay, x, we have x here and y there, and we have m too. M is what? M is this one. So we all put this in the so we say that y is 180, and we have this one 60. M is 60 kilometers. See, y is 180 is equal to m 60 times x. What is x here? X is 3. 1 point. See, the coordinates of one of the points, the point 2 is 3x and y is 180. Always, the first one is x and the second one is y. Always. Never changed. And so we say we have this equation, and we say we don't have c. We don't have c. because I will tell you later why we don't have C. You know, this one started from origin. If it started from here, then the C was 60. Now so let's finish this one. C is equal. This is 180, and this is going to go this. We keep this one in one side, and the other one go this one here is 180 minus 180. It's going to be 0. So the equation is going to be y. 60x plus 0, which we don't write 0, 60x. So equation of this line is y is equal to 60. See, the x is, we are talking about, this is very important here. This is f of t, y, in kilometer. And this one is t, x was t, 6t. Means, you know, if you put any number for t, like t is 1, t is 2, t is 3. If it's t is 1, we can draw this one. You know, ignore this one. We find a function, this one, and want to draw it. This is t. This is f of t. This is a function of t. Means whatever we change the t, this is going to change. See, if it's t is 1, this is going to be 60. And, you know, if you put the unit, means 1. And then at the second hour, this is going to be this point. At the first hour and the second hour. See? You see that? And if it's 0, if the 0 time, at 0 time, what is going to be? You know, we put the input-output value here. If it t is 0, t is here is 0, okay? We say t, and then f of t, or y. The t is 0. T is 0. F of t was going to be? F of t is equal to 60t. And then 60 times 0 is going to be 0. Whatever you multiply any number by 0 is going to be 0. 0 of 1,000, 0 thing. There's nothing of thousands of zeros. 0 means there are thousands of nothing. So if we put it 1, this is going to 60 times 1 is going to 60. And if it's 2, it's going to be 60 times 2, it's going to be 120. See here, we have the equation, we have the function, you know, and then we put the value there. And see, this is the same thing. This is y is equal to 60t. Means you can change the time, and this one is going to change. Okay, just I want to tell you this, that what does kilometer per hour means. Kilometer per hour. Now you want to change it to meter per minute. Meter, to change it to meter per minute. Right, m it means, this one, m means meter. Now we finish this one. So what you're going to do? Every hour is going to go. See, like for example, it's at this example is 60 kilometers per hour. We want to change it to a meter per minute. How many meter in minute? Okay. So the way to do it, we say that 60 times things. I write the unit here, right? Okay. We're going to multiply by this. First we are going to eliminate, change this one to meter. So 1 kilometer is going to be 1,000 meter. Meter is m. Call it show it by m, kilometer by km. And then we cancel this out, okay? Now it's 60,000 meter per hour. Now we are gonna change this one to minute, okay? If somebody asks you what's going to be how many meter, we are going to change this one kilometer per hour to the meter per hour. So that's the answer now. It's going to be 60,000 meter per hour. This is per hour. Also, we are going to change it to minute. If you said we are going to change it to hour, and this is the answer. 60,000 meter per hour. Okay. Now we are going to change it to minute. We are going to change this to minute. What is that? 60 kilometers per hour. We are going to change it to meter per minute. The most common way is meter per second. You know, in physics, in most places, you want to change it to meter per second. Okay, so this is going to be. We say 1 kilometer is 1,000 meter, and 1 hour. See, this cancels out. But we're going to cancel hour to minute. So 1 hour is going to be 60 minutes. So these hours cancelled out, and this is going to be 60 times 1,000. See, 60 1,000, and we write all these. You know, this is multiplication. 6,000. 60 times 1,000 divided by 60. 60 cancels out is 1,000. What is the unit of meter? This is going to be meter per what? Per minute. This is the only things left from us. Meter at the top and minute at the bottom. So 1,000 60 kilometers per hour, it means that 1,000 meter per minute. Okay. So the units are very important things in math and science. So let's talk about converting other units. Let's say 8 foot. See over the top distance, like kilometer. This is feet. It's just measure of the distance. You know, this is, we say 12 inches. There are 12 inches in there. One foot, it's 12 inches. We see 1 foot, 8 foot per minute. See, a car is going 8 feet, every minute is going 8 feet. I mean, this the toy, that remote control toy, it's going very slow. 8 feet per minute means every minute is going 8 feet. Now we're going to change it to inch per second. We showed second by S, or we can read sec, means second. Inch per second. We say 8 feet per minute times. Okay, we are going to eliminate feet here. 1 foot is 12 inch. Okay, this cancels out. Now we are going to talk about minute, the time. Times, this is times, okay. We say 1 minute is equal to 60 seconds. So we are going to change this we are going to change to this feet per minute inch per second. So the result will be 8 times 12 divided by 60. Now we simplify, divided by 2, 30, divided by 2, 6, divided by 2, 15, divided by 2, 3. So, and 3, this is divisible by 3 because 1 plus 5 is going to be 6, 6 is divisible by 3, it's going to be 5. So 8 over 5. 8 over 5. We cannot simplify more than that. So it's going to be inch per second. 8 inch, every 5 seconds is going to go 8 inches. Every 5 seconds. Okay? Or if you want to divide this one, you can write it in a decimal, you know, you can write it in decimal way, 1.6 inch per second. Means that every second is going to go 1.6 inches. Later on we are going to, you know, talk about this because units is very important, you know. So we will talk about that, give you more example later on. Okay, we have still time. We have still time. So we find out the speed. The speed, we find the speed is 60 kilometer with a speed. Kilometer per hour. We could change it to minute, to everything, but there are so many other things that in units, you know, we have to learn the units of the acceleration is meter per second square. We usually they write it in meter per second. Velocity, they can write it in meter per second too. It's a distance divided by time, and again it divided by time is gonna get the acceleration. So I just tell you, see, mg is the force. I'm going to talk about unit. This is a kilogram, and g, this is meter per second square, and this is kilometer. But so it's going to be kilogram meter per second square. This is the unit of force in metric system. So we will talk about the converting and the energy is going to be what? Energy